In this video, we're going to look at how to figure out the area of a figure when it looks like you're not given much information. All you're given is some unknowns, and you're given maybe a little bit of a measurement, one measurement, and it just looks like you don't know enough. Well, if that's the case, you're going to have to use algebra to help you. So in this particular example, we have a swimming pool, and our swimming pool is 3 times as long as it is wide. And you also know that it's surrounded by a deck that's 2.5 meters wide. So it looks exactly what you would think it looks like. So for a swimming pool, I'll shade it blue because we have water in it. That's the swimming pool, and it is surrounded by a deck that is 2.5 meters wide. So for example, as you're walking along the deck, the width right here is 2.5. Everywhere along the deck is 2.5 in width. It doesn't look that way because I didn't draw it well, but you get the point. All right, so here we know that since the pool has a length which is 3 times as long as it is wide, we can go ahead and label the width x because it's unknown. So I'm going to label that x right here, and that is 3x because it's 3 times as long. All right, so let me just make sure it's clear what that 3x is for. All right, and this is for the length going here. All right, we also know that the width of the deck is 2.5. So from here to here is 2.5 meters long. And I'm not going to write my units because I don't want them to get in the way when we set up our algebra, but just know that that's supposed to be 2.5 meters. All right, so now what do we do? Well, we know that, let's see, we know that the area of the deck is 265 meters squared. So that part that's not shaded, so I'll point to that. This part here, the area is 265 meters squared. Now, if you recall from when you learned about the area inside a figure, so it's not the whole figure, but a part of the area inside a figure, in order to find a part of the area of the whole figure, we have to first find the area. I'm going to say area of the total, that's everything, the pool plus the deck, is going to be equal to the area of the pool plus the area, I'm trying to get this to fit here, of the deck. I'm just going to use an A so it fits. So the area of the pool plus the area of the deck will give you the total area. So now we can go ahead and try and fill out some information that we have. So we know the area of the deck, right? What's the area of the deck? Well, the area of the deck, according to this, is 265 meters squared. All right, so I'm just going to put it here for now and see where it leads us. All right, as far as the area of the pool is concerned, well, we know from our picture here, or diagram here, that the length of the pool is 3x and the width of the pool is x. So we know that the area of the pool is 3x times x, which will of course give us 3x squared. All right, so we're getting somewhere with this, and we're going to pause for a second. All right, so now we need to figure out, well, the area of the whole thing. And you may be asking yourself, well, how can I find the area of the whole thing when I have absolutely no information? Well, you actually have some information. So here's what you do know. We know that from here to here is x. As you can see, from here to here is x. We also know that the walkway is 2.5 meters wide. So that means, okay, so from here to here, I'm labeling the same thing I just showed you. That's x, but the walkway from here to here is 2.5. Now the walkway extends on the other side as well, so from here to here is also 2.5. So that entire thing here is x plus 2.5 plus 2.5. And that gives you x plus overall 5. Now we can go ahead and do the same thing for the length. So we know from before that this is 3x. So of course over here will also be 3x. And up above the walkway is 2.5. And below, sorry, that's my dimension label. And below we have also the walkway is 2.5. So overall, that whole length is 3x plus 2.5 plus 2.5, which gives us overall 3x plus 5. All right, so now something is coming together. Hopefully you see that we have an expression right here for our length of our entire thing, and an expression right here for the width of our entire thing. And we can use that and fill it in for the area of the whole figure. So we have here that 3x plus 5, and remember that area is length times width. So 3x plus 5 times x plus 5 is an expression for the area of the whole thing, length times width. And that would give you what we figured out before. So we have here, and I'll rewrite everything, we have here for the area of the total 3x plus 5 times x plus 5 is equal to 3x squared plus 265. Now this looks like something that we probably should be able to solve. So I'm going to take this equation and I'm going to turn the page. Okay, so briefly recapping here, we know that this is the area of the whole thing because of what we did with the dimensions. This is the area of the pool because it was 3x by x. And this is the area of the deck, and that was told to us in the original question. So now we can go ahead and we can multiply our expression here, and so we get 3x squared plus 15x plus 5x plus 25. And that is equal to, and I'm not changing anything on the right side yet, equal to 3x squared plus 265. All right, now we can go ahead and join our like terms, and we get that 3x squared plus 20x plus 25 is equal to 3x squared plus 265. All right, so if we're trying to solve this, we want to get everything, all our x's over to one side. So we can go ahead and subtract 3x squared from both sides. And conveniently so, that goes away. So now this equation starts to look a lot simpler. We have here 20x plus 25 is equal to 265. All right, so in order to solve this, we want to get that number, the 25, over to the other side. And so we have here that 20x is equal to 265 minus 25, and that gives us 240. So finally, we can divide both sides by 20, and we get here that x is equal to 240 over 20, which is 12. So x is equal to 12. So going back to our original question, where we had the swimming pool and we had the deck, and this was x and this was 3x, now we can tell that the dimensions of our swimming pool is x, which is 12, by 3x, which is 12 times 3. So that is 12 by 36 meters. Now we can drop those units back on because it's really not good to leave off your units. And now we're done.